Hello, Dr. Jessie. I'm ShaffiahM. I have selected experiment setup number 1, which is comparing machine learning algorithm. So I'll go through the models that we have selected for comparison purpose, the result, and also the best performing model from the comparison. So machine learning algorithm that we have chosen here is to give a fair comparison. Therefore, it is evaluated on the same dataset. As our problem is a standard binary classification dataset, choosing the right machine learning algorithm is based on trial and error. So we have applied 4 different classifiers and added in one more dummy classifier to create a baseline for the machine learning algorithm. The 4 has been listed here: decision tree, k nearest neighbor, naive Bayes, and support vector machine classifiers. Table 4.1.1 here represent the summarized result obtained from each machine learning. For decision tree classifier, we have applied 4 different settings. For parameter default and entropy criterion with a max depth of 3, we uses 2 data sample size to try and error on the train and test sample size. Just to test the water before we decided to go with the 80-20 ratio. Test and validation accuracy for entropy criterion with accuracy is 0.72, while the F1 score is 0.61. For Gini criterion, with or without random splitter, we get an accuracy of 0.65 to 0.66, while the F score remains at 0.65. As the data is imbalanced and machine learning algorithm favors larger class, we will not focus on the accuracy result, but we will focus on the F1 score, which is the main of the precision and recall. While we ran the algorithm for K and N classifiers, the weighted average F1 score was between 0.60 to 0.66, where parameter tuning for n neighbors of 29 and weights distant as weights produces highest F1 score of 0.66. For naive Bayes, which is Bernoulli and Gaussian algorithm with a k-cross validation varies from 5 to 10 and 90. We also did binarize, which is mapping to Boolean, has been tuned from 0.0 to 2.0. Even though the test and validation accuracy can go up to 0.72, but the F1 score remains around 0.60 and 0.61. We did explore support vector machine algorithm. Unfortunately, it takes longer than expected to generate result. Polynomial and radial kernel SVM algorithm did run successfully with F1 score of 0.60 and a highest accuracy of 0.72. We have selected the K K-neighbor classifier as the best performing model with comparing to other 4 machine learning algorithms. The parameter selected was n neighbors of 29 and weights equals to distance, which produces the best F1 score of 0.66, or we say 66%. Why do we choose neighbor of 29? It was because when we run and we try to determine the best number of neighbors while hypertuning, it shows that neighbor 29 will give us the best score, highest accuracy. As we have imbalanced data set, we try to stratify data using SMOTE, S-M-O-T-E, synthetic minority oversampling technique. And below is the overall result that we have obtained using SMOTE. Baseline classifier remains the same, which gives us a 50% accuracy and 52% of F1 score. But other classifiers F1 score dropped tremendously to range between 0.45 to 0.64. Like the original dataset output, KN classifiers produces the best F1 score. So we come to a conclusion that K-neighbor classifier has been chosen as the best machine learning algorithm for our case study. Thank you.